Okay, I think we're recording now. Yep, this is March 9th, 2017. RChain new program working group, and we're looking at the bank account example, which was from the Rosette 1.1 manual, and we're trying to run it in Rosette here. And we found that Google Documents replaced the quote character with a funny quote, and that screwed us up. Okay, we created a bank account. Def OPM, OPRM, define operation withdraw, define operation deposit.
Mm-hmm.
Those had to be, we had to declare those before we could make methods.
Yeah, and before you, I guess, define the methods within the actor.
Right, and then we're creating an actor called the bank account.
Yep.
And then now we have slots ampersand.
Yeah, that's just a way to say the, like it's, I believe it was a way to say it's a meta slot. Or no.
Well, this is
Sorry.
This is creating an instance variable, balance.
Sure, you can think of it that way. Yeah.
I can think of, okay, I guess I should read the manual.
No, I think that's
okay, but
like a fine
if I wanted to keep something else like number of transactions, how would I do that?
Like you want to add another slot?
Yeah.
You can just keep going.
Keep going in the same list? Name, value?
I believe so. Can't find the Rosette.
How can we keep Google Docs from using bad quotes? That doesn't make Google Docs very useful in this context.
Yeah, that's true. It's not meant for code.
I guess we could always update those.
I think.
Except the bogus quotes. No, well. But basically, I have it here in Notepad. I just don't have the indentation, which I could add. I don't know why it doesn't copy the indentation either.
Yeah. This tab's not important for me. Yeah.
Whatever. You're not sure how I add another slide, huh?
Oh, no, you can just keep going. That I confirm that.
I can say I can add like count like this.
Yeah, just
0, and then I could do something like update count plus count 1, and then it would keep a count of the number of withdrawals in this case.
You might need to add another parentheses at the end there.
Oh. Yeah. Okay. Then under withdraw, I would do the same thing. But
the one issue is that for some reason I'm getting a site fault. I don't know. Maybe it's just me.
what do you know what this update is for?
The update is what essentially like unlocks the actor, I believe. So like it, how should I say it? So like until the update is called, like if you change the balance or I don't know, it's done something, it's still processing the incoming call, I believe. And then when you, I don't know if I should say it's similar to a transaction commit. I feel like it's a bit different, but
Yeah, I thought that's what it must be.
yeah.
Oh, isn't it when you call update is when you get parallelism? It starts the next process. It starts processing the next message.
Yeah, so that's the unlock part.
The unlock.
Like when you
Okay,
call
so
update, it the actor gets unlocked and like essentially able to continue processing or receiving messages, should I say?
Okay, so so now we can now I can make a new bank account, and oops. So let's see. The way I would do that is I would just say define.
Yeah.
My account is a new bank account. Oh, I have to cheat now. New bank account. That works, right?
Yeah, just add two ending parentheses.
Okay, and then I can say my account deposit 500. Deposit. Um, any idea what that error might be?
Missing method deposit. You have to call deposit first, I believe, and then it's the actor.
I'm sorry?
You have to call deposit first, and then you have to call the actor. Like the order of the syntax is such that it's my account 500, I believe.
What?
So the order of the syntax is like deposit, my account 500.
Okay, I deposited 500.
Yeah. Second argument is not a float. Maybe you have to give it a float.
Oh.
Well, I mean, I think it passed.
I expected that, but it still says it deposited 500, but it probably...
Yeah. I think it's fine, yeah.
But I have no way of getting the balance of...
That's true. You need to add a method.
Can I add a method now? That's the question.
That's a good question. I believe you can do def method, get balance, and then the actor name, which would be bank account.
Oops.
See if that works. Oh, no. You have to... It's def method, the actor name. And I haven't really tested this out. And see something. Balance and or get balance. And just return the balance. Oh, but of course you have to define the operation. So yeah, okay. So once you get the balance, you have to define it.
So I have to do a def OPRN.
Yep.
And I balance and then I'm going to try this again.
Oh, I see why you want that. Okay.
Does that mean I have a balance method now?
Ooh, I believe so. You named it the exact same thing. I don't know if that works. That means.
Yeah. Well, I'm trying to, give it, the idea of programs as data. We're constantly programming against our data, building rules upon rules, type thing here. So we have balance, my account. $1,000.
Nice.
Sweet. Um, Let me paste 500 point instead. And what did that do? Didn't say anything. Isn't it supposed to return something?
Yeah, it's supposed to return deposited. I don't know if that's the way you define floating points. Maybe try
It's
0.
very silent. Let me try, I don't know.
You want to try 0.0? Like, I mean 500.0.
Oops, wrong thing. Now, why did I get a balance this time? A balance before. Balance
Right.
my account 1,000. Maybe I screwed. Maybe I completely screwed up my bank account.
uh, um,
Let me try this again.
You want to define it without the float? I mean, there's no reason that you have to put 0.00 at the end.
Well,
Well, okay, I mean, you can do that, but then when you define 500 dot, maybe add 2 zeros too. Does that make sense?
well, the problem is I lost the balance. So when I deposit here, this is when I broke it. Apparently. This is a little bit scary if it's that fragile.
Yeah, it's pretty fragile.
I
don't know. I still haven't. It also
Okay,
crashes on
it says
previous.
deposited 500. Now, what do the brackets mean again? That's a tuple, right?
Yeah.
And that's just I guess I'm wondering what the utility of returning a tuple is as opposed to
Just returning the thing.
well, returning a list, I guess would be a program, right?
Well, there's no that's basically a list. You can just return the number, I believe.
Balance my account. 1,500. There we go.
Yep.
So when I tried to put an integer amount into a floating point that add with a returning value, and it got an error, it replaced the I did a
Mhm.
when it did the plus with a floating point and an integer, it returned an error value and it stored that in balance.
I don't know if it's stored the error value. That's something.
Okay, and then I couldn't get the balance anymore.
Yeah, I mean,
Stepped on
I'm
so
wondering though if it's because of your later call to deposit in which you.
but no, by that time I already wasn't getting balance.
Well, because you put in
And when
an
I put
invalid floating point.
and when I tried to put in any more at that point, it got an error because balance was neither an integer or a float anymore. Balance was a non-value or something.
Do you know? Well, okay, I can test it out.
Yeah, I'm fairly certain. Okay, so we succeeded in that. Okay, the next thing I wanted to try was creating another actor that has a bank account.
Mm-hmm.
And then a method assets, which spits out the bank account balance.
Mm-hmm.
Okay, and this Jim Scarver actor is something I want to program dynamically on our network of nodes to become me, so that when I'm no longer here, you can still talk to me.
Method assets. Bank account.
Okay, well, let me paste this in Notepad here because I don't have the right quotes in. Let's see, and I need FOPRN assets. Assets?
Yes, that's the method.
What happened to my parentheses here? And then and okay, here I call the balance method, which it's sort of which we didn't have before.
Yeah, you would want to define it.
So we needed to define that.
I think it's already defined as a function.
Yeah, I know. I'm just trying to capture that for the notes.
Got it.
And that was just this.
Yep. I mean, it's cleaner to now just add it to the bank account definition. I think. I don't know.
I guess. Oh.
Can I modify the document?
I'm sorry?
May I modify the document?
Can you, I mean, if you're logged in, you can suggest.
I was just asking. Here.
Oh, no, don't put it there.
How come?
The idea, I mean, the point was to do it separately, modify.
Oh, sure. Okay. Fair enough.
Add a method to an existing actor. Okay, we're starting to program things differently now, dynamically.
Sure.
Okay, so we have the def OPRN assets. And we did that, right? Did we do that? No, we didn't.
You might get that quote.
Well, here we have it, right? Put it here. And where do we have the quote? We don't have any quotes in here. We don't need, oh, we have one here.
Yeah.
Make sure that's the right quote.
Maybe we can just stop using the tuples and just return the value. I don't know.
Well, I like, no, I like this. Now, I guess what I was thinking of doing next, and I don't know if Gary has any other idea about this, what he wants to do. But I was short of parentheses somewhere. So
You might have, no.
I mean,
You have one too many, actually. When you define the actor, or here,
yeah.
I can just change it on.
So this parentheses here, I don't know where that came from, right?
Here, I changed that on the doc. Yeah, I think you got it. But.
Okay, so I created an actor, and it has a bank balance. And so now I can define the method separately. Assets. And that should be in parentheses. I'm going to just go back to the beginning here. Depth method assets, and that simply returns and we're returning a tuple. We're essentially labeling the fields that we return in essence. I'm not sure what else it is. Bank balance. Bank account balance. And that's the end of the define method.
Yeah.
Formula mismatch.
I think you have to call balance before bank.
Oh, right. Duh. I'm backwards.
Yeah, it takes a lot to get used to, I feel.
Yeah, I taught small talk for over a decade at NJIT. And so I'm writing object method, not method object.
Yeah, me too. Definitely.
Balance bank account. I find it very interesting that this is object actor language instead as an object function language.
Yeah.
And of course, this is functional also.
Well, don't the actors sort of take the place of functions? Aren't they sort of a higher order function?
It could be. I mean, supposedly everything's an actor, right? But when we define X as 5, okay, it's like a primitive actor. Whereas when we do an actor, we're defining a real actor. I don't know what the exact difference is.
Yeah, I don't think I would say the actors are functional because you modify their state, and that's kind of, I guess, against the idea of functional programming. But I don't know. I would like to say that actors are essentially objects.
Yeah, they are, and you can certainly make in any object-oriented language you can make an actor, but it's not the normal way that objects don't have mailboxes.
Well, they have, I guess, instance variables, member variables usually. So.
Okay, so I got a formula mismatch here.
It
says bank balance. Duh. Oh, that's right. Bank balance is fine. It's a literal that I'm returning. And then I do the balance of the bank account. And the bank account is one of my slots where I have a slot bank account.
Indeed. Yeah, the error message is interesting. Form is usually it's like passing the wrong arguments to function is how you get that.
Now, because I defined this function separately, maybe I can't access? No, of course I can. In the last example we did, adding the balance function, it could access the balance. So I can access the bank account here. Oh, wait a second here. I didn't say what I was adding the method to.
Yes.
Duh.
Yes. I didn't notice that.
Wake up, Gary. We're supposed to catch those. Definitely.
My mute was on and I didn't.
So I want to define a method in Jim Scarver, the Jim Scarver actor, which is assets. Okay, and I'm going to put and you know, and the next task I made for myself is probably undoable, but we're going to make this the quote bank balance, which is going to be the balance of my bank account. Okay, and end the tuple, we end
Typo in there.
that method. I'm sorry? Oops, I spelled it wrong. Thank you, Gary. Depend on it.
Just doing my job.
You have to earn your keep. Of the bank account, and the end of the tuple, and the end of the def method. And I guess that worked. F-O-op, what does that mean? You know?
That just means you've defined an operation. Or I mean, that's the actor for the operation, should I say.
Okay, so now if I do a assets of Jim Scarver, I get a bank balance of 1,000. Okay, now the next thing, the next exercise that I gave for ourselves was they had a hello method, which we've already.
Hello method?
So,
What does a hello method do?
well, I was just gonna, you know, I was just gonna have it say hi there, but then I was gonna modify it so that it would go through a list of greetings.
Just like hello, hey, what's up?
So let's see.
So this is a concurrent operating system or concurrent virtual machine.
Right.
And it's also distributed. So if Kent's running one on his computer, how could he link his computer to your instance of Rosette?
I don't know exactly how Rosette is set up to do that. Can you tell us, Kent?
So it's not inherently concurrent. I mean, sorry, not concurrent. Distributed, because I mean it has NetIO methods, but in that sense, it's just like every other
Right.
programming language.
That's that's exactly what I was thinking of in terms of if we all ran an instance on the net. Okay, we could just talk to each other in Rosette.
Yeah, well, through primitive methods that open sockets, and yeah. But that would be
I mean,
exactly
the way it's exposed now. Okay, okay, if I wanted to talk to this is another instance of Rosette, right, that's running on my machine.
Yeah.
So I can
So you could
I could basically open a socket to that here.
yeah, either instance could create an actor. And
Yeah, well, the Jim Scarver one is on this version. The other one doesn't know about Jim Scarver. But if I wanted to, I could dump the Jim Scarver object, right? How do I do that?
What do you mean by dump?
I want to dump the code for the Jim Scarver actor.
There is the dump code, I believe, method, but
so
I don't know if that's what you're searching for, because
you really want all the code that's been entered into your.
I actually want the source. I want it in source format.
Right. Everything you've done so far, you would like that in a file.
Well, that
right?
too. That's something else I want to do. Now, why did it say that? Dump code. There's no command.
It's not dump code in camel case, but okay, sorry, it's code dump code, and it's also not camel case. It's with a hyphen.
What?
It's code dump. Yeah. Also not camel case.
Not capitalized? What?
Not camel case. It's with a hyphen. Yeah.
Okay, this gives me the machine code.
Not exactly the machine code. First of all, you have to put in a compiled code object. So you have to compile Jim Scarver. And I believe it also has, the compile has to be an operation. So like as a simple example, code dump, compile, quote.
So really, Jim, what you want is a history of the commands inputted so far.
Well, I want code as data. I want to see the code for the Jim Scarver object.
So you want to see the Rosette base language code that results from what you've input so far?
Right.
So,
well, and yes, that's the way that you develop systems on this type of it's really an operating system that we're using.
Yeah.
They changed it to virtual machines later on. So really, you just want a list of all the bindings, don't you?
Well, I mean, if I wanted to move the whole thing over, that would be true. But I just want to move over the Jim Scarver object right now, or the bank account actor. I want to see the current code for the bank account object, which would include.
Yeah, the thing is, you need to serialize the binary object, which there's no method right now.
So we could do that. We just have to write the code for it.
Okay, we could write that in Rosette, right?
Yeah.
Well, you have to write it probably in C++, because I believe that will be a primitive.
You're saying there's no easy way to get back to the code.
Well, you can dump the opcodes.
The opcodes we can dump.
Yeah.
But getting from the opcodes to source code, or from the opcodes,
well, to be able to mirror it on a different machine, you also have to essentially get
dump code, right?
binary objects for it.
Where's the code dump?
Code dump, yeah.
Code dump.
Yeah. Should I just screen share?
What?
Should I just screen share? I don't know. I can show a few examples. I don't know.
Sure.
Okay. Can you see that?
Yeah.
Okay. So we have code dump, and we want to compile. So we're going to pull 5 and then here we get, these are the opcodes. And this is the expression that, like, what I believe is that there needs to be a way to like serialize this part out, the literal vector. And yeah, I'm not too clear about that part, just a little bit. But yeah, that's mostly it. I don't know if you can actually just like compiling dump an actor itself. No, you can. Wow. But yeah, so yeah, I think that's about it. One thing did you have something that do you want to go on with the hello example, or like I just wanted to show the factorial example that Greg showed.
Okay, go for it.
With you? Okay. So I mean, specifically the factorial with a continuation, because I thought that was kind of neat. So I think in a previous session we covered the regular factorial, should I say? So that should give 120. Yeah. But the issue with this is that it creates a stack frame for each time you recurse through factorial. And so there'll be, I guess, 5 stack frames for fact 5.
Right, fact 5, of fact 4, of fact 3, of fact 2, of fact 1.
Yeah. And so we don't want that, I guess, that build up, should I say, because that could blow off the stack. And so what Greg showed me was the continuation passing factorial. which essentially does the exact same thing as the factorial, except it takes in a continuation. By doing this, you can essentially collapse the stack frame. And I'm guessing it's at the end. Yep. And so yeah, now you can call k factorial 5. And
what's walking slippers?
Sorry, we didn't catch that.
What's walking sleepers? Sleepers. A whacking sleeper.
Oh,
Okay.
sorry. This is me trying to understand the C++ implementation. I turned the debugging options on.
Okay.
I manually turned on some. Yeah. So, and I believe if I just pass in the method print, it should just print 120. Yeah. So here, what it's doing is it's basically the normal factorial plus it's passing in the print method. So each time it makes a call, instead of simply just creating a new stack frame, it gets the result, and then it calls the print of the evaluated value. And
what are you saying? The print? What is it?
So essentially what it's doing is that, normally factorial will end up doing something like fact of 5, or no. 5 times fact of 4, right? And then this will in turn become like 4 times fact of 3, as you just mentioned. But instead, we can make it so that we print. The print is just, the way to literally print. Yeah, ignore these messages. It just prints that. And so here, if you can see, I don't know, they tell me you should follow the recursion, but when you call kfact of 5 of print, this becomes kfact of 4, right here. Right, so just to go over this part, if n is less than 2, that's what it's saying, do this stuff. So just ignore this part for now. And so in here, what happens is you end up calling kfact proc of print of 5 times the value x. And so this essentially you keep recursing down until you hit here where k is print. So it essentially passes print into, it passes print into here, and it ends up just calling through each, or how should I say it? It ends up basically just printing out the accumulated result.
Now, if you didn't put print there, if you didn't do a print, wouldn't it would return the value of?
Yeah, so one thing I could do instead is I could pass it, I don't know if this would be valid. I can't add 1 to the method. I could pass something that requires the result. So what else is there? Another proc maybe? That should double the result. I'm not mistaken. Yeah, it does. Because, so it gets the result of kfac, which is 120. And it passes that into the value of x. And then we add x to x, so it doubles it. So 120 goes in, doubles, and then, I mean, it automatically is printed out. So yeah, that's why you see it on the screen. And yeah, I mean, that's, I don't know. I just thought it was neat. And I mean, just to see how continuations in Rosette work. Yeah.
Okay, so I guess what I don't understand here is, I guess the proc.
The proc is, you said, did you ever do Pascal?
Proc is like an anonymous function?
Yeah. Exactly. I would say like a lambda. I don't know. It's just a Python.
Yeah.
Yeah.
So you're saying that the proc of x is k.
Yeah. So
times n x. But
I mean, do you see what happens when you do just, for example, maybe this is easier for a start. Kfac 1 print. It simply goes into this case, right? Because n is less than 2. And so we're just doing print 1. And that's why 1 gets printed. And so if we do...
Again, I'm still not sure why if you just put 1 in there, it wouldn't work.
If you just put 1?
If you didn't put K1, if you just put 1 in there, wouldn't it still print the 1?
Oh, but yeah, let me recall. So basically, no, like it needs the factor or the continuation, because the continuation is being accumulated. So what you're passing in is not just print, but you're actually passing in the new proc into here. And so, sorry, I think I might have said this a bit differently earlier, but essentially you end up passing 1 into the proc here, which contains the print. Does that make sense? So what it ends up looking like is, so just let me paste this code right here. So what happens is we get proc of 1, and we get the print function.
Hello? Yeah. All right, good. Good. How are you? Yeah, she is. She's been hold on a second. Sorry, I gotta get the scroll, huh? Second. Sorry about that.
Welcome back. So yeah, just continuing off. So what happens is it becomes proc of 1, and then I'm just kind of relabeling this, times n times the value x, which is 1. So this is what happens. You see that?
Yeah.
Like, so you can't just have 1 here, because then you're not, then it just prints 1 all the time, if that makes sense.
Right. So k-fact of n k is less to it is k1. Also, it does k-fact of n minus 1 proc so you're
I mean, you see why you need that k before the 1?
I don't.
well,
what is k? What is the value of k if we're doing k-fact of 2, for example, by the time it reaches here?
that
Because
would
we're going through the recursion here, right? So the first, for when k-fact 2, it ends up being 2 minus 1, which is just 1. And then this proc, right? So when you call k-fact of 1 of this, right, it ends up going back in here. And this time, because it's less than 1, it ends up being k of 1, which is just k. This is the new k of 1. And then now 1 gets passed into the proc here. And then this is just the print function, because the old k here was just the print function, if that makes sense. This is like the new k. That might be a bit confusing, but and then it ends up, just doing print of the value 2, because this is the old n, right? This is not the new n. This is the old n times 1, which was just passed in. So it just prints 2, which makes sense.
okay. So in the end, when we do k space 1, we're doing okay. We're saying that k is the proc.
Yeah, k is the proc, the whole thing.
And we're given, and x is 1.
Yeah, x becomes 1 because here you're passing 1 into the prop. This is the prop, right? This is this thing. So you end up passing 1 into x here.
So in essence, you're building up K. You're building up in K the whole expression.
Mm-hmm.
5 times 4 times 3 times 1, which you're then printing.
Yeah. Yeah, you got it. And I mean, just to explain why this is relevant, like, you know, the tuple space gets metrics that Greg has been talking about. It uses the continuation. If you look at the code, just to, I don't know if it's gonna work well. I mean, if it's gonna paste. Oh yeah, it pasted well. Wow, yeah. So, you know, this is the get of the tuple space semantics, right? In here, I mean, I don't know. I mean, we can just ignore this for now. But here, we can see how
it looks like this is what you want, exactly what I wanted in terms of getting the source.
Yeah, I don't know. It just pasted, which is kind of magical. I didn't expect that. The prop, we're passing in essentially the continuation here. And again, this is basically all just continuations being passed through. Yeah, so, I mean,
now, what is it we're looking at here? How did you get this?
oh, this is on the mobile process calculi. I mean, I'll paste the.
Oh, you just pasted something in here?
Oh yeah. I mean, this is what, I don't know.
Okay, because you
I still didn't grasp
the def method namespace. So this is code you pasted in from that Greg wrote to define a namespace.
Yeah, I don't know if Greg wrote it, but I mean, he definitely understands it.
Okay, so wow, this is going to be pretty heavy.
Could you go back to that factorial?
Mm-hmm.
Yes. So from what you've done there of that, what you've done, the difference between fact and k-fact is you have now produced a factorial that flattens the growth of the stack.
Yeah.
And
exactly.
it still achieves exactly the same result.
Yep. Indeed.
And is that a standard method of doing that?
I guess not, because this is the standard. Like, that's the normal factorial.
Well, no. What I mean is that a standard method of getting around the the geometric growth of the stack in a recursive call system.
Yeah, I mean, yeah. Tail recursion optimization or tail call optimization. I think there must be a Wikipedia article on it. Tail call optimization.
Well, the thing is, I've seen this before, but that's the first time I think I ever understood it exactly that way.
Interesting. Okay.
And that's, you say Greg showed you how to do that?
Yeah.
Well, that alone was worth the session today.
Good to hear, or
Yeah.
glad to hear.
Well, yes, definitely get this recorded and uploaded. This is good.
Okay, I mean, that's kind of it for what I have. I would like to get to lunch soon too, if possible. Is that good?
Yes. I can think of all kinds of questions, but I could probably post most of them to the Slack.
Got it. In that case, I guess goodbye.
I'm sitting here on mute. So you're showing us here the namespace definition?
Oh, yes.
So, a method in the namespace. I'm not sure. I guess the point there was you were showing us the same techniques were being used in there. I'm not sure what.
Yeah, exactly. So the continuation passing technique is used inside there.
And essentially, a proc is a continuation then.
No.
No?
Not exactly. A proc could just be a proc. Or I mean, sorry, that's not. A proc is just an anonymous function, as you said before. Or,
Yeah.
a lambda.
Yeah. And I guess.
But I mean, a proc is used to do these continuation passing. Yeah. I mean, you need some kind of, I guess. I mean, or at least if you're doing it.
You need an object that's code, and that's what the proc is.
Sure. Yeah. I think I'll be going off to lunch now. But I mean, do you have anything else?
I don't today, Kent. Thank you very much, as always. Please keep us in mind, and maybe we can learn more next week.
Got it.
Thank you so much. Have a good lunch.
See you.
See ya.
Bye.
All right. So we want to wind down here, or?
Yes, we can stop the recording.
Okay. Have a good one, everyone.